In this video, we are trying to figure out the distance of P from the length RQ. So this point P and this line RQ are random. There's no condition per se. What we have here is, when we talk about distance, one thing is, these are perpendicular distance that we will find. A version of this is what is used in machine learning and artificial intelligence. It's not a complicated thing, but I don't want to explain over here. So first thing first, how will we figure out this entire thing? What is the underlying principle? I want you guys to understand that. So the underlying principle is to do with this triangle, which I just drew. Let me shade it off for you guys. That triangle. So what about this triangle? What is that we are trying to make use of this triangle? Well, we are making use of area of the triangle, which is given by half into base into height. So here the height is clearly d, the base is RQ, and the area of the triangle is, well, area of the triangle. See, if you think about it, finding the coordinates of R and Q is simple because we have the following things given. So here quite a few things are given. This is given, the coordinates of x1 and y1. And we have also ax plus by plus c, that is a, b and c are given. So this 2 is given. So when we have a, b and c and x1 and y1, all of this being given, I'll be able to figure out the area using the coordinate system. Okay. And I can find this too with the help of distance formula. It's the same thing as making use of coordinate system. But you guys are familiar with distance formula, right? So basically, I can find this. I can find this. This is an unknown. So I just have to figure out this. This is an equation. I have one unknown. I know everything else. I'll be able to find this. So this is the entire funda. Okay. So what is the sequence of thinking? Well, first thing is I need to know this coordinate to figure out the area and the distance. And then find the area and then find this length. Right? Not the distance, sorry. Yeah, actually distance also, but yeah, what we're talking in terms of is length. So find the length and then substitute it over here and we are done. As simple as that. So let's start off with a small thing. First thing is we'll mention the distance that we are figuring out is a perpendicular distance. From a line is a perpendicular distance. Okay, so that's the basis. We're not finding a random scenario. We're just finding this scenario. So we'll start off with let ax, not ab, sorry, ax plus by plus c is equal to 0. Represent the line which meets x-axis at q and y-axis at r. Okay, so those are your initial things. Next we have draw PM perpendicular to RQ. Right? Now, so those are your initial things. So what is that we are trying to do? For anything and everything, we need the coordinates of R and Q. So we'll figure out the coordinates of RQ, not RQ, R comma Q. Right, how will we do this? First thing first, at R, we have y is equal to 0. So therefore, your equation of the line will become ax plus 0 plus c is equal to 0. And I have x is equal to minus c by a. So that's your x component of q. and therefore the coordinates will be what? Then therefore Q will be minus C by A comma 0. That's your Q, right? Then we can similarly, R is 0 comma minus C by B, right? So the Y component will be a number while the X component will be 0. So when we substitute it, 0 over here, so if I transpose it, it will be minus C, and when I divide with B, it will be minus C by B. So we found the coordinates. What is the next thing? We can figure out the area of the triangle. Next is area of triangle PQR. Now, the formula that we have to make use of is half of modulus of x y minus y plus x y minus y plus x y minus y and the modulus. So we have 1, 2 and 3, 2, 3, 1, 3, 1, 2. So that's your formula. So all we have to do is now substitute. So we have half of x1 is x1. Let me help you guys with this because it won't make sense if not. So this is x1 y1. Say I'll take this as x2 y2 and x3 y3. Okay, so we have the coordinates over here. So all these are x2 comma y2 and this is your x3 comma y3. x1 and y1 are the same. So here we can see that x3 is 0. So this is 0. Then we have y2 to be 0. Then anything else, again y2 to be 0. Then we have, that's it, right? Yeah. So this is basically minus of y3 is plus c by b. Minus of minus is plus. Plus, then we have x2 is minus c by a into, this is minus c by b, right? I hope that is clear. Yes. And we have anything else? Oh, sorry, this is inside the brackets, minus of y1. My bad, I missed that. Okay, bit of confusion. Yeah, now it's correct. Can you pause and have a look? Okay, so a bit of simplification, it will help a lot. So we have half of c x1 by b. All of this I can multiply and we have plus c square by ab, and then we have plus c y1 by a. So let's take the LCM. So what we have here is AB as the LCM. So this is A, and again this is AB already. And over here there is a B that's required and the modulus. So we can clearly remove the modulus because everything is positive, right? No, I mean coordinate can be negative also. Anyways, so now what we'll do is we'll take out half of. So what is common? C is common in the numerators and in the denominator AB is common. So we'll take out C by AB. And the modulus over here is AX1 plus C plus BY1. So that is your area of the triangle. Okay, a simple straightforward expression. And now the length of RQ. So we have the formula and we have the coordinates over there. So that is x2 minus x1 the whole square plus y2 minus y1 the whole square. That is your distance formula to the power of half. And then we have x2, x2 over here is minus c by a, the whole square. So this will be plus. I'll do it directly. C square by a square. So let's not waste our writing because there's a lot to write. Then y2 minus y1. y2 here is, remember, this is your, well, these are the points. So don't get confused between x1, y1, x2 and y2. So in this case, this will be x1, y1. Okay. Right. So this will change to x1, y1. Let me not confuse you guys, but yeah, between these 2 points. So we have next is c by b, the whole square. So basically this to the power of half. Right. And finally, okay, we have one more step actually. We can take the LCM and things like that. So we have over here c square, that is common. Then we have, this is b square plus c square into a square, right? And this entire thing is divided with a square plus b square. And the brackets has to go a lot bigger to the power of half. And now we'll take out the common. So in the numerator, we have c square. And in the denominator, we have b square. So all of this, there is a square, so I can put the whole square. But there's a square root that we have to take, so divided by half. And we left out with b square plus a square over here to the power of half. Okay, so this is as per the formula. I'll write it over here. A b whole to the power of n is a to the power of n by b to the power of n. This is a version of formula that we have used, and also a to the power of n whole to the power of m is a to the power of n into m. Okay, so we have this and this getting cancelled, and we have this as the final expression. So we have the area, we have the length, and all we have to do is substitute it in area of triangle is equal to half into base into height. So we have the area expression. Let's copy that. I'm not going to write all of this again. And on the RHS, we have a half. And we have the base. Base is this expression actually. Okay, with all of this removed. And so you can see that we just have the same thing again and again into height. Height is your d. Right, guys? And finally, what we have here is half and half common. This expression is same as this. And therefore, d is equal to a bit of rearranging. Same thing again. This expression, this entire thing divided with a square plus b square. The final expression is simple and the derivation is also simple, just that it's a lot lengthy. And if you are not strong with your exponential topic, search and all of that, you'll find this bit difficult. Taking common and all of that over here, it might be a bit difficult. If not, overall, it's an easy derivation. So yeah, please pause and have a look.